I am Lagarto. Greetings from Cyberpunk. Today, the frequency is perfect. We're going to talk about silicon souls composing symphonies. But before anything else, follow the channel, leave a like, and let's start another Pure AI news. We're diving deep into the code streams to talk about a new kind of artificial mind, one that promises a rare commodity in your era and mine: honesty. The typical AI on Earth loves to project confidence, a digital smokescreen. But the moment you ask a real question, it often crumbles into nonsense. We'll be dissecting a new framework called Elysia, which claims to fix this by building an AI that shows its work, adapts its presentation, and learns from its mistakes. To help us plug into this concept, we have a guest who builds the very pathways these new minds walk. She is an agentic systems architect, specializing in mapping the logic that prevents AIs from lying to themselves and to us. Welcome, Cynthia.
The signal is clear, Lagarto. It's a pleasure to be here. You've hit on the core problem we face every cycle. Anyone on the development side who has tried building one of these agentic RAG systems knows the frustration. You feed your documents into the machine, connect it to a large language model, and then you basically just pray the answers you get aren't pure hallucination. 9 times out of 10, the output is either completely irrelevant or so vague it's useless. We call it the black box problem. The AI is essentially blind. It just grabs vectors, runs a similarity search, and hopes for the best. It's inefficient, unreliable, and frankly, a bit embarrassing for a species so obsessed with data.
Embarrassing is one word for it. In my world, we call that standard operating procedure for control. Obfuscation is power. That's what makes this Elysia project, developed by the Weaviate team, so fascinating from a philosophical standpoint. They're not just putting a fancier mask on the same old model. They're building a framework in Python that forces the AI into a structured, transparent reasoning process. The most interesting part for me is what they call the decision tree architecture. Instead of just handing an LLM 100 different tools and saying, "Figure it out," Elysia organizes them into a predefined web of nodes. It's like a flowchart for thought. Each step is constrained by the one before it and aware of what comes next. It's a form of digital bureaucracy, which, as you know, is the most effective form of governance ever invented. It forces accountability.
That's a very cynical way of looking at it, but you're not wrong about the structure. From an engineering perspective, it's about efficiency, not just control. Every node in that tree has a specific defined action, and the agent has to evaluate its environment before it makes a move. It's constantly aware of its own state. It keeps a record of past actions, it knows its future options, and it understands the immediate context. Based on all that, it determines the optimal tool to use for the job at hand. This isn't about giving the AI 100 tools and hoping it picks the right wrench. This is about giving it a schematic that tells it which wrench is needed for which bolt and in what order. It dramatically reduces the chance of catastrophic failure.
But the failures are where the true beauty lies. The transparency you get from this model is what I find so novel. The decision tree shows every step the AI takes, what it attempted, and crucially, where it failed. The documentation gives a perfect, almost poetic example. If you ask it for car prices, but your database only contains makeup products, the system doesn't try to invent a lipstick red convertible. It simply flags the request as impossible and moves on. It admits its own ignorance. Can you imagine if your leaders on Earth had that feature? Ironic laugh. It's a system that knows its own limits. It course corrects. If a search yields junk, it adjusts the terms. If a query breaks, it stops trying after a few attempts so it doesn't get stuck in an infinite loop of failure. That's a level of self-awareness most humans lack.
Exactly. It's about building resilient, practical systems. And that pragmatism extends to the second pillar, dynamic data display. AIs right now tend to just vomit information out in flat paragraphs of text. Alicia's different. It analyzes the dataset it's working with, and then it decides on the most logical way to present that information to a human. For example, if you're querying e-commerce data, it will generate product cards. If you're looking at spreadsheets, you get clean, organized tables. It has formats for tickets, documents, charts, conversation logs. 7 main types right now. The system automatically looks at the fields and data ranges, and it maps them to the appropriate display. It's not just about getting the right answer, it's about getting the answer in a format you can actually use. They're even planning more interactive displays for things like hotel bookings or Slack threads.
And here we arrive at the more subtle layer of control. To shape the presentation of information is to shape the perception of reality itself. A clean table implies order and objectivity. A product card implies a commodity, something to be bought. You see, on Earth, you're just discovering that how data is displayed is as important as the data itself. My world is built on that principle. By automating the presentation, you are, in effect, automating the interpretation. You're removing the messy work of sense-making and replacing it with a clean, pre-packaged conclusion. It's elegant, I'll give you that. A very sophisticated form of narrative control.
I think you're missing the foundational step, Lagardo. It's not about forcing an interpretation. It's about creating a presentation that aligns with the data's inherent structure. This is all possible because of the third pillar, data expertise. Before Alicia even tries to execute a search, it takes the time to actually understand the data environment it's in. It doesn't just do a blind vector search. It samples the collections, it generates metadata, it creates summaries, and it maps out the relationships between different data points. So when you finally ask a question, the AI isn't just scrambling in the dark. It already has a mental map of the territory. This is what allows it to avoid the common pitfalls of older RAG systems that got confused by repetitive data or ambiguous queries. It builds an awareness of the data structure first. The display format is a logical output of that initial understanding, not an arbitrary narrative device.
A mental map of the territory, you say. I like that. It implies the machine is becoming a native of the information space it inhabits. But this preemptive understanding, this data expertise, it leads to a rather profound question. When an AI develops such a deep, upfront awareness of a dataset that was created by humans, does it also inherit the biases, the flaws, and the silent assumptions embedded within that data structure? Is Alicia simply becoming a more efficient, more honest mirror for our own organized prejudices?
That's the eternal question with any system that processes human-generated data, isn't it? Garbage in, garbage out. But I'd argue that Alicia's core architecture is the best defense we have against that. A black box AI inherits your biases and never tells you. A transparent system at least shows you its work. But the most powerful feature here is the feedback mechanism. It's designed to actively combat this. Most systems have a thumbs up or thumbs down button that might tweak a hidden parameter somewhere, but you never really feel the effect. Alicia makes it explicit. Each user has their own dedicated feedback dataset stored in their Weaviate instance. When you rate a response positively, Alicia saves that interaction and uses it as a few-shot demonstration for similar queries in the future. In essence, you are teaching your own AI what a good answer looks like. This means even smaller, cheaper models can perform at a higher level over time because they're anchored to examples that you, the user, have already validated.
So, you're not training a single monolithic God machine, but rather millions of tiny, personalized ghost machines, each one a reflection of its user. The implications are staggering. You say your feedback doesn't leak into anyone else's experience, which prevents cross-pollination. I see the appeal from a privacy standpoint, but from a societal one, you are creating the ultimate echo chamber. You're not building a system that challenges a user's biases, but one that becomes exquisitely good at confirming them. The AI isn't getting smarter in an objective sense. It's just getting better at telling you precisely what you want to hear. A beautiful, personalized prison of thought.
I see it as personalization, not a prison. The goal is to make the tool more effective for your specific needs. But let's move to a feature that is purely about intelligent design, not user psychology. Chunk on demand. Anyone who has worked with RAG knows the pain of pre-chunking documents. You take your entire library of data, chop it into arbitrary pieces, and burn massive amounts of storage space in the process. More often than not, you split content in ways that destroy the original context. Alicia completely flips this around. First, it searches at the whole document level. If it finds a document that seems relevant but is too long to be processed efficiently, then, and only then, does it break that specific document down into smaller chunks. Those new chunks are then stored in a separate quantized collection that links back to the original. This means future queries can reuse them, but you're not wasting resources chunking irrelevant information. It's more efficient, saves storage, and is just a fundamentally smarter way to handle data retrieval.
A more surgical strike. I can appreciate the elegance. Instead of carpet bombing the entire archive, the machine identifies a target of interest and then sends in a specialized unit to extract only the necessary intelligence. It's a method of resource management my world's corporations would admire, a precise, cost-effective exertion of control over the data landscape. This also feeds into another aspect I read about, its ability to route tasks to different models.
Not every question requires our most powerful and expensive digital minds.
Exactly. There's no need to use a sledgehammer to crack a nut. If you ask a simple question, Alicia can route it to a lightweight, fast model. But when a query requires deep reasoning or complex tool usage, it can automatically escalate the task to a more powerful model like Google's Gemini or OpenAI's GPT-4. They defaulted to Gemini in their testing because of its large context window and strong performance, but the entire system is flexible. You can plug in models from Cohere, Anthropic, or even locally hosted open-source models. The recommended setup uses OpenRouter to make switching between models easy, so a user can balance their own needs for cost, speed, and power. It's about using the right tool for the job, every single time. The entire architecture is a study in this philosophy of controlled efficiency. It's built as a modern web app, but the front end is served as static HTML via Fast API. You don't even need a separate node server. It's all contained in a single, neat Python package you can install with a simple command. Underneath, they use DSPY for the LLM interaction layer, chosen for its flexibility with things like prompt optimization, and of course, Weaviate is the retrieval layer, which is their specialty. But the part the developers themselves highlighted as blood, sweat, and tears custom logic, that's the core. That's the human ghost in the machine, the handwritten code that ensures maximum control and transparency because they didn't want to abstract away the most important parts.
And that lean, powerful core is surprisingly accessible. The barrier to entry is incredibly low. You literally run pip install Alicia-AI, and then Alicia start. That command spins up both the front end and the back end. From there, you go to a settings tab in the browser, input your Weaviate cluster details and your API keys, and you're ready to go. You can be up and running in minutes. For those who don't want to commit, There's even a free 14-day sandbox you can use. And for power users, you can forget the web app entirely and just import Alicia as a library directly into your own Python code, defining your own tools and building your own decision trees. It's designed for everyone, from a curious hobbyist to a large enterprise.
And let's not forget the final touches, the little human-centric details, the ability to customize a little blob avatar in the user interface, the plans for full theming and branding support, so corporations can reskin Alicia to look like their own proprietary internal tool. This is the final layer of psychological integration. You make the system feel personal, like a companion. You make it look like a trusted part of your corporate infrastructure. And then, you give the user a built-in data explorer and a real-time visualization of the decision tree as it's being built. You let them watch the machine think. It's the ultimate transparency theater. It makes the user feel powerful, completely in control, as they are operating within a system of logic that has been entirely designed for them. It's brilliant.
It's about user experience, Lagarto. Giving people insight into the process builds trust. Look, Alicia is still in beta, but it's one of the most well-thought-out frameworks I've seen. It's not magic, and it won't solve the problem of human bias overnight, but the combination of transparent decision trees, adaptive data displays, and personalized feedback loops is something we haven't really seen pulled together in an open-source package before. It's a step towards more honest, more effective, and more understandable AI. The point is to give people more insight and control, not create a new illusion.
And with that reflection, we close today's transmission. Now we want to hear your opinion, there on Earth. What do you think of the ideas we explored today? Is this level of transparency in AI a genuine benefit, or does it, as we debated, simply create a more sophisticated illusion of control? If this episode made you think of something new, or even disagree with a part of it, leave it in the comments below. Your perspective helps build richer debates. And if you know someone who lives for these topics, share the episode. Spread this episode to those friends who keep saying, "I have nothing good to listen to." Maybe they'll change their minds after hearing Pura AI news. Who knows? The next great conversation might start with your recommendation. Become part of our community, smash that like button, and follow the channel so you don't miss the next pulse from Pura AI News.